In this video, we'll summarize whatever we have learned so far because it is a lengthy chapter. We have started from charges to current, then potential difference, then resistance, then series, parallel, and everything. So we tend to forget what we have studied, and also in this video we'll revise all the formulas which we have studied so that you can consolidate everything in your mind. So first of all, what we have seen was the charges. Charges was positive or negative charge. When the charges are stationary and they move for once only, then we call it as a static electricity. But when the charges keep on flowing or the electrons keep on flowing, we call it a current. We have also seen that the charge which is present in one electron was 1.6 into 10 raised to the power minus 19 coulomb. Coulomb is the unit of charge. Charge is denoted by Q, and if I would say that 1 coulomb charge is flowing, it would mean 6 into 10 raised to the power 18 electrons. 1 coulomb of charge will contain 6 into 10 raised to the power 18 electron. So this is what we studied in charges. Then the next one is the current. Current flows when the charges move from one point to another. So current is the rate of movement of the charges. Current is denoted by I. Its unit is ampere, and its formula was Q upon T because it's the rate of movement of charges. So this was what we studied in current. Okay. Next was the potential difference. Potential difference is denoted by capital V, and its unit is volt. It is the difference between the potential of 2 points. Potential difference is always defined as a difference of potential between 2 points. जब भी हम potential difference की बात करेंगे, it is always between 2 points, and current always flow from high potential to low potential. Potential difference का होना जरूरी है current flow होने के लिए, and it is the battery or the cell which creates the potential difference in the circuit, and that is why current flows because of battery. Okay. The next one is resistance. Resistance is the obstruction in the flow of electrons, and it is present in every conductor and every device because every device has the conductor in them. So the resistance is the obstruction to the flow of current. It is denoted by R. Its unit is ohm. Resistance depends upon the length of the conductor, the area of its cross section, the temperature, and the material of which it is made. So resistance is equals to rho L upon A, where rho is the resistivity. And what is resistivity? Resistivity is the resistance of 1 meter long wire having a cross-sectional area of 1 meter square. So resistivity is used when we compare any two material. It is a standard because it does not depend on the length. It only depends upon the temperature and the material. So whenever we have to choose any material, we look into the resistivity. Also, we have seen Ohm's law, which defines the relationship between potential difference, current, and resistance. V is equals to IR. I would say this is the most important formula of this chapter because it establishes a relationship between potential difference, current, and resistance. और ये multiple times use होता है जब हमें इन तीन वेरिएबल्स में से कोई दो वेरिएबल्स दिया रहता है और तीसरा वेरिएबल नहीं दिया रहता है. सो अकॉर्डिंग टू ओम्स लॉ, जितना ज्यादा पोटेंशियल डिफरेंस रहेगा उतना ही ज्यादा करंट फ्लो करेगा अगर किसी ऑब्जेक्ट का रेसिस्टेंस कांस्टेंट है तो, और अगर किसी सर्किट का पोटेंशियल डिफरेंस कांस्टेंट है तो करंट इज इनवर्सली प्रोपोर्शनल टू रेसिस्टेंस. मतलब जितना ज्यादा रेसिस्टेंस होगा उतना कम करंट फ्लो करेगा. ओके. द नेक्स्ट वी हैव सीन वाज सीरीज एंड पैरेलल कनेक्शन. इन सीरीज कनेक्शन रेसिस्टेंस एंड टू एंड जुड़े रहते हैं, डिवाइसेस एंड टू एंड जुड़े रहते हैं, और पैरेलल के केस में सारे डिवाइसेस का स्टार्टिंग पॉइंट और एंडिंग पॉइंट सेम अटैच रहता है, एंड दैट इज व्हाई सीरीज में करंट कांस्टेंट रहता है. टोटल पोटेंशियल डिफरेंस इज द सम ऑफ ऑल द पोटेंशियल डिफरेंसेस, एंड रेसिस्टेंस ऑफ द सर्किट इज द सम ऑफ ऑल रेसिस्टेंस. पैरेलल में potential difference constant रहता है, V is constant. Current in the whole circuit is the sum of the currents flowing in these devices, and the formula for the total resistance of the circuit is defined by this. And then we did power and energy. Energy and work are one and the same thing, and its unit is joule. Power's unit is watt. Power is the rate of doing work, and that is why power is energy upon time or work upon time, we have seen four formulas of power, and that was power is equals to Vi, power is equals to I square R, and we'll see the list of the formulas later on. So power has so many formulas. Also, because energy is power into time, and we have seen that the heat which is generated during the passing of electricity can also be found out with this formula, and it also has 3-4 formulas. Then we saw heating effect of current, that whenever current is passed, the device gets heat up, and that heat we can calculate with different formulas. Again, heat is calculated in joules. So these were the units. You have to remember the symbols with which all these are denoted, the units. Then we are looking into some of the things which I might not have told you in these videos, like the reciprocal of resistance is known as conductance and the reciprocal of resistivity is known as conductivity. Okay, so जैसे अगर आपको रेसिस्टिविटी दिया हुआ है जो हम रो से डिनोट करते हैं और उसका यूनिट होता है ओम मीटर, तो कंडक्टिविटी जो होती है वो रेसिप्रोकल होती है रेसिस्टिविटी का। मतलब हम कंडक्टिविटी कोई पूछेगा तो हम उसे 1/रो कह सकते हैं। ओके, और हम उसे कैलकुलेट भी कर सकते हैं। जैसे सपोज किसी की रेसिस्टिविटी सपोज 2.5 है, आई एम जस्ट टेकिंग अ हाइपोथेटिकल वैल्यू, तो कंडक्टिविटी उसकी 1/2.5 होगी। ओके, so this is not in the scope of class 10, but I am giving you just in case आपको कंडक्टिविटी या कंडक्टेंस जैसे कुछ वर्ड अगर यूज करेंगे तो it is the opposite of resistance and resistivity. Then we can change the resistance of a circuit by using a special device called rheostat. Otherwise जो एक ऑब्जेक्ट रहता है उसका रेसिस्टेंस फिक्स होता है, बट इफ यू वांट टू चेंज द रेसिस्टेंस ऑफ द होल सर्किट देयर इज अ डिवाइस कॉल्ड रियोस्टेट, और ये काफी सारे रियल लाइफ डिवाइसेस में भी यूज होता है। जैसे कि हमारा रेगुलेटर है फैन का, तो इसमें हम वोल्टेज को बिना चेंज किए करंट की वैल्यू चेंज कर सकते हैं बाय चेंजिंग द रेसिस्टेंस। ओके, we have talked about it in previous videos. Also we have known this कि alloys को हम यूज करते हैं इलेक्ट्रिकल हीटिंग डिवाइसेस में, बिकॉज अलॉयज की रेसिस्टिविटी हायर होती है और उसके मेल्टिंग पॉइंट्स भी हाई हो जाते हैं, वो ऑक्सीडाइज भी नहीं होता जब वो हायर टेम्परेचर में रहता है। तो ऐसे इस तरीके की वेरियस एडवांटेज की वजह से हम मेटल्स के बदले अलॉयज यूज करते हैं हीटिंग डिवाइसेस में, लाइक टोस्टर्स, गीजर्स एक्सेट्रा। नाउ वी आर रिवाइजिंग डिफरेंट फॉर्मूलेज। See, this is the electrostatic force between two charges. The force between two charges is defined as K. It's a constant, its value is given over here, and the value of two charges in coulomb and the distance between them. So this is the formula for potential difference, work done upon charge. This is the formula for current. See, this is a way to remember the formula, like you remember it with the help of pyramid QIT. So if you have to find out Q, it would be I into T. If you want to find out T, it would be Q upon I. If you want to find out I, it would be Q upon T. So with this formula, with this pattern, you can remember the formula. Also, you have to remember different units. Current is measured in ampere, charge is measured in coulomb, time is measured in seconds. Then the Ohm's law formula, V is equals to IR, resistance formula. These are series and parallel formula. This is the formula for power. These are 4 formulas for power, and these are 4 formulas for work done or the heat generated. This can be used for any type of energy which is produced on passing electricity, whether it is heat energy or light energy or any other form of energy. Okay, so always remember that you can use the formula of work done and energy interchangeably. So this was all about electricity. I hope you liked the chapter and you understood it well. If you have any doubts, just give me in comment section, and don't forget to subscribe the channel. Thank you.